Hi everybody, welcome back to Climate Change Calculated. Today, what can be done about e-mobility? My name is Gerald Schuller and this is my little assistant, Althans. Okay, so let's start. First, the introduction. So first let me say that I'm against identity politics that label us as good and others are bad, because climate protection requires everyone's participation, not just a single group. Therefore, I present straightforward numbers and facts. What counts are ideas, regardless of the persons they are coming from. Yeah, so I guess as everybody know, the problem is the global CO2 emissions. So this year we have another record high of 41.6 billion tons. So you can see that here in my reference number 2, Statista, global CO2 emissions. These references are also listed at the end of this presentation and also below the video. Yeah, and the consequences of this increased CO2 are calculated in my Climate Change Calculate series, which you can find here listed on our university website. In episode 2, I compute the rising global temperatures, and in episode 3, I compute the sea level rise. And what's interesting there is that you can actually compute those yourself with simple school mathematics and physics. For these effects, you don't need sophisticated models, just school physics is sufficient. So the goal here is to reduce our CO2 emissions. So the aim or the goal would be to reduce the CO2 output to or below 1950s levels. And I calculated that in my episode 1. So I found if you go back to the 1950s levels, that's enough to not further increase the CO2 concentration in our atmosphere. But if you want to actually lower the CO2 concentration, we have to go below 1950s levels. So that's actually a lot. Yeah, so how can we do it? So it seems a promising approach is the CO2 pricing approach. So this is in a way similar to wastewater treatment fees. So basically, if you create waste, you have to also pay for cleaning up the waste. So the question is, what does it cost to clean up the CO2 in this case? And there are actually technologies in direct air carbon capture. And depending on the source where it's captured, it can be, for instance, at the smokestack of a power plant, or somewhere from the air, it's between $134 and $432 per ton. So the most expensive is right out of the air outside. So capturing CO2 directly from the air is more expensive, thus avoidance is preferable. So let's say $300 per ton might be the cost. Demand for such technology is growing due to legal requirements leading to further developments, which can be seen here in this reference from Fraunhofer. Yeah, which also shows that the pure amount of CO2 that we have in our atmosphere means that we don't really have enough technology to absorb it. So that's another reason to avoid it instead of trying to absorb it. Yeah, if you compare this now to the current EU CO2 prices, then you can see that it's not quite fitting. So we are now having 62 euros per ton CO2 price, and it actually went down during 2024. And we saw in reality it should be more like $300 per ton. So we need roughly 230 euros per ton more than we have now. So that means this adjustment would also increase gasoline prices, and in this way promoting fairness and encouraging emissions reductions. Basically, if you cause damage, you should also pay for it. Otherwise, everybody would pay for the damage that somebody else causes. So this is basically the CO2 price as a damage tax, applying the polluter pays principle to fossil fuels. So this is comparable to water usage and wastewater treatment fees. And this encourages the adoption of cleaner technologies and practices because that also saves them more money. Yeah, technologies benefiting from this CO2 pricing are electric vehicles, EVs, more on that next. Then renewable energy sources, heat pumps, which avoid burning fossil fuels. And these technologies become more competitive as CO2 pricing reflects the true cost of emissions, the damage that needs to be repaired. Yeah, and electric vehicles are a kind of low-hanging fruit because they're already there. So EVs offer an immediate opportunity to reduce emissions. The transition to EVs should be as soon as possible to significantly lower the CO2 output. And the manufacturing and operation emissions are lower compared to internal combustion engine vehicles over their lifespans. So you can compute that it's actually a lot lower, and it's also paying financially. There are calculations for 5 years, keeping an electric vehicle for 5 years, comparing it with a internal combustion engine car. And over those 5 years, it's usually much cheaper to have an electric car, even though the purchase price might be higher. Yeah, and another advantage that we have from this electrification is the versatility that it offers car designers. So one of the possibilities is to make it a software-defined automobile. And Tesla basically invented it. It leads in reimagining cars as software-defined vehicles. And the definition is that significant properties are determined and controlled by software, which makes the cars more versatile and adaptable. It's a little bit like the transition from normal lamps to LED lamps. Previous lamps, they had like only limited form factors and always the very similar light color. And with LEDs, much more different shapes were possible, different colors, light colors, and so on. And this versatility then also helped the breakthrough of LED lamps. And I think this will be similar for electric cars. They offer more different types, possibilities of cars. They have much smaller electric engines. They don't need big coolants. Then they have a relatively compact battery, which can be made in different shapes. And that will allow much more versatility of cars. And software-defined automobile is one of those possibilities. Yeah, and one of the features that software-defined automobiles offer include internet connectivity and a browser on a large screen in car, transforming the car into a mobile office with cloud services. That's something I actually enjoy a lot, having this big screen in my car that allows me to open a browser and access my data in the cloud. Yeah, and it also enables over-the-air updates. So previously in conventional cars, they just age, they don't become better with time. But software-defined automobiles, they get updates like smartphones, and in this way become better over time. So little improvements. Tesla has over-the-air updates since around 2012, so they were the first, and many other manufacturers are still catching up. It's actually not so easy to have over-the-air updates, and many other manufacturers discovered that it's not so easy. So that's why they are still catching up. And users can choose when to install updates, such as in the evening after arriving home. Basically like a smartphone. They ask you, shall I install an update? And then you can say, yeah, do it now or do it maybe this evening. So you can actually set a time to do it. And examples of recent updates include the enhanced autopilot capabilities. So it's always getting better over time. Tesla has many cameras around the car, a big computer, and since everything is electric, you can let the computer control many important properties like steering assistance, emergency brake assistance, lane keeping, automatic lane keeping, and many more possibilities. And this actually also increases safety of those cars, because with the many cameras, you always have everything in your field of view. It's not like a human, which can only look into one direction. So if you look behind, then you don't see what's in front. Cameras can do it all at the same time, and they are always attentive. They are not distracted by anything. So that improves safety a lot. So I actually drive a lot, and I noticed that this really is important. Yeah, it also includes improved display interfaces like the user interface, then navigation system enhancements like including stops in between or detours, or weather radar integration in navigation. And here's a website where you can see more detail on what Tesla updates are doing, not a Tesla app, which I find quite interesting. Yeah, so e-mobility I find simplifies transportation a lot. It also lowers the cost per 100 kilometers because it's much more efficient. So when you compare the energy efficiency between electric cars and combustion engine cars, they are about 3 times as efficient, and as a consequence, they are about 3 times cheaper than gasoline cars per 100 kilometers. They also offer tax savings, and they also have reduced maintenance requirements because there's less wear and tear, because there's no high temperatures and no high pressures, unlike in combustion cars. That means there's less wear and tear, and that means less maintenance, fewer repairs, no water change, no oil change. If there's something with the car, it will tell you because it has many sensors and the computers, so you don't need to worry, basically. That's great. It just drives as it should be. Yeah, so this is my personal experience with EVs. I have a Tesla, and it's now about 6.5 years old, and it already has 200,000 kilometers on it, so it shows I drive a lot. And my Tesla remains the best car I've owned, so I'm still enthusiastic about it. There was really nothing with it, no repairs. It's very reliable, and it always works. It is also economical and convenient in operation. I can conveniently charge it at home using a standard outlet, or can charge during shopping, like at shopping malls, typically up to 90% because it's better for the battery, depending on the battery type. Also, the charger is integrated in the Tesla navigation system. So if you do long distance trips, it automatically plans the charging stops for you. It knows where all the chargers are, all the superchargers, and it also knows the occupancy because they're all connected to the internet. So it automatically routes you to the charger where you have a free charger when you come. Very convenient. There's for other cars, there's also a better route planner. That's a smartphone app for long distance travel. And I usually combine rest breaks with supercharger stops. So when I'm at a supercharger, I go to a restaurant or a coffee, have my break, and relax, and then I continue with my long trip. On the other hand, home charging ensures that the car is fully charged anytime I leave the house, or let's say 90%. So I don't need to worry about it. So it's also very convenient. So in my everyday commute, I never need to go to a gas station. So that's actually also very nice. Yeah, so my Tesla has a 75 kilowatt hour battery, and it has an energy consumption on average of roughly 16 kilowatt hours per 100 kilometers. And I have a daily commute of roughly 100 kilometers. And that means at a normal home power outlet of, let's say, 3 kilowatt, this takes about 16 divided by 3, which is 5.3 hours overnight to recharge. So I can easily charge overnight. So on long distance, while keeping the battery between the charging states of 10 and 90%, this means I have a range of about 380 kilometers. So I use 60 kilowatt hours for that range, and at a supercharger with typically about 120 kilowatt, this takes about 30 minutes. Well, it's actually a good time. Actually, when I go eating, I want to have at least 45 minutes, so it's actually a little bit too fast for me. But if I'm in a hurry, I can also stop charging and leave anytime I want. Yeah, an important point is also the battery longevity. Many people worry about it because it's an expensive piece. And I found this interesting investigation here. It's a dissertation from Technische University of Munich about the types of lithium-ion batteries that Tesla is using. And you can find many data in it, and one of it is that after 20 years, the battery maintained around 90% capacity, the state of the art, state of health, if you keep it at medium charging levels. So if the charge level is kept between 10 and 90%. Yeah, so this is actually pretty good. And let's see. Oh yeah, another important point is here the calendar life. So one type of aging comes from the charging cycles. So you have 2,000 charging cycles, and a calendar life of about up to 30 years. So they say usually much longer than the life of a car. I myself have noticed no battery degradation after those 6 years and 200,000 kilometers, so that's pretty good. And 2,000 cycles, when you take the full cycle, that would be, in my car, roughly 500 kilometers from 0 to 100. And then that means 2,000 cycles mean about 1 million kilometers. So that's also much more than the typical car life. So even after those 2,000 equivalent full cycles, so roughly 1 million kilometers, the batteries retain over 80% capacity. So that's pretty good. Yeah, interesting is also the purchase price. So EVs, because of the lower prices for lithium-ion batteries, are expected to reach price parity with internal combustion engine vehicles by mid-decade. So that's already next year. Right, and the falling prices contribute significantly to this trend. So you can see this in this link, EV price parity. And some cars already have price parity this year, and next year, 25, more cheap EVs are expected to be introduced. So that will be interesting to observe. And this development will make EVs more accessible to a broader consumer base, because it will be cheaper, since the purchase price is not more and the maintenance is actually much cheaper and is more reliable, which means you have less loss of value in the car. It makes it financially much better to buy an EV than an internal combustion engine car. So after that time, more car purchases will be EVs than it will be internal combustion engine cars, ICE cars. And that also means that internal combustion engine cars will lose value faster because there will be fewer people buying used ICE cars, and the demand for used electric cars will increase, and because there's less wear and tear, they will last longer. So that means they have less loss of value. So it's another important property. Yeah, and when buying a used EV, this actually becomes more and more feasible because there are more and more used EVs available. I found a good resource here is this one here, EV Clinic. So that's actually a car garage which specializes on electric vehicles, and they have experience in and they actually here have a survey of the different car types and how good they keep up over time. So this is actually quite interesting. Yeah, so that leads me to my conclusion. E-mobility presents a practical and effective solution for reducing CO2 emissions. Electric vehicles offer numerous benefits, including lower operational costs and reduced environmental impact. With advancing technology and expanding infrastructure, transitioning to electric mobility is becoming increasingly accessible and advantageous. Yeah, and here I have my references. Here the next page of the references. Yeah, and that leads me to the end. Yeah, thank you for your attention, and then see you next time. Bye also von Altans. Okay, bye-bye.